welcome to our first level 1 tables, equations and graphs video. We're just going to recap on coordinates. Remember, coordinates represent a point on the Cartesian plane. This is a diagram that is called the Cartesian plane. We have what we call an x-axis, and a lot of people remember it as x going across. And we have a y-axis, and a lot of people remember it as y to the sky. The point where the x-axis and the y-axis meet is called the origin. Right, so a coordinate is two numbers written inside brackets separated by a comma. For example, inside brackets 4, 2. We always put the x value first. So the first number represents going across first, and it's the second number, which is the y value, which is going up and down. Right, so let's go through some examples to recap these. Here's the first coordinate. What is the coordinate of this point? Well, you can see we have to travel 4 across and 2 up, so we write it as 4, 2 inside brackets. All right, example 2. Here's another point on the Cartesian plane. What is the coordinate of this point? Well, we've had to travel 9 across from the origin and 1 square down. So it's going to be in brackets 9, -1. All right, here's our third example. What is the coordinate of this point on the Cartesian plane? Once again, we start at the origin. We have to travel 2 squares to the left from the origin and 3 squares up. So we're going to go in brackets -2 because we've got to go -2 to the left, and then 3 means to go up 3. All right, what about this example? What is the coordinate of this point here? Well, notice we've traveled 4 squares across from the origin, but we then have not traveled up or down. We haven't moved vertically. So it's going to be in brackets 4, 0. Right, what about this example here? Well, starting from the origin, we must move 3 squares to the left and then 1 square down. So we're going to go in brackets -3 to the left, and then in bracket, comma, -1 means go down 1 square. All right, well, let's do a couple of examples that are a little bit trickier to finish off with. Let's have a look at this Cartesian plane and this coordinate called point A. What's the coordinate of point A? Well, some people might think I've moved 1, 2, 3, 4 squares across and 1, 2, 3 squares up. But unfortunately, this is not right because we've got a different scale. If you have a look at here, each square, every time we move across 1 square, we're not counting up in ones because we've got to travel up 1, 2, 3, 4, 5 squares to get up to 10. So if each square can't be 1, each square must be equal to 2. So therefore, if we count across in twos, 2, 4, 6, 8 across, we've travelled 8 across, and then we're counting up in twos, 2, 4, 6 up. So we've gone 8 across and 6 up to get to the coordinate 8, 6. Right, and the last tricky one to finish off this video, what is the coordinate of point B? Now you can see on the x-axis we're representing hours, and it's going up in 1 hour, 2 hours, 3 hours, so that's going up in steps of 1. But on the on the vertical axis, the y-axis, we've got cost, and that's going up, counting up, the numbers are in hundreds, 200, 300, and so on, but we've got smaller increments in between. So that is 3 across, right? We're happy with 3 across. But when we count up, it's not going to be, we're not just going to count how many squares up I've traveled. Now have a look at this part here. We've got 4 increments to get to 100, 4 to get to 100. So if we go 100 divided by 4, each increment vertically is 25. So if we now work out where point B is, you can see that it is up to 300, and then it's 1 more square or increment above 300. Each square or increment's worth 25. So 300 plus 25 means we're up to 325. And the coordinate is 3, 325. Cool, thanks so much for watching.